Right, so quiz 7. The mode is the value that occurs the most often, right? So you line those values up. You don't even need to really line them in order, but typically just look for the one that occurs the most. And we're really saying that the mode is a type of average, aren't we? It's a type of average. So it's one of the averages. So it's a value that occurs the most. Okay, that's question 1. Okay, right. So, question 2. Our first task, of course, here in terms of standard deviation calculations is to find the mean. So first of all, find the mean. 66 plus 51 plus 69 plus 50 plus 57 plus 61. Yes, divided by, well, 1, 2, 3, 4, 5, 6, 6 items. Yes. Where are we? Here we are. 66 plus 51 plus 69 plus 50 plus 57 plus 61 divided by 6 items, and that takes us to an average of 59. So now that we know that that is 59, we literally now find, if you like, we have x, 66, 51, 69, 50, 57, 61. Change my pen color. Now we know what the mean is. The mean is 59, 59, 59, 59, 59, 59. And then now, of course, we then also have the x minus the mu, which is the 66 minus the 59. Here we have 7. 51 minus 59 is 8. 69 minus 59 is 10. That's minus 9. Well, it doesn't matter. We're going to square all of these anyway. That's minus 2. And that is 2. 61 minus 59. And then we now square it. X minus mu squared. So you have 49, 64, 100, 81, 4, and 4. And then add them all together, right? And that's what we're doing. So very quickly, 49 plus 64 plus 100 plus 81 plus 4 plus, 4 is equal to 302. I get 302 divided by the number of entries, 1, 2, 3, 4, 5, 6. So 302 divided by 302 divided by 6 is that, and then find the square root of that, and I get 7.09. 7.09. It's possible in my adding I might have been wrong, but that's the process. Just add all that, find the square, and add all that together. That's what that means there, the sum of all that, and then divide by the number of entries, and then find the square root of that. Yes, cool, great stuff. And that is question 2. Okay, so with mixed variances, I think I've been keen to stress that we're really interested in the mix, just the mix. So the idea here is that the plan is that you are to mix 30 liters of A with 20 liters of B. That's the point here, and these are the costs at a cost of 4, at a cost of 5. That is the structure. That is the plan. So we're interested, like I say, firmly in the mix. Right. So here, what we have here is that the first thing if I remember highlighting, is that you always want to find out what that total was. So you did a total output of 11,000, and then you had for A, and then for B, and then for A you had 7,000 liters of A, and then you had 4,000 liters of B. And so I suppose the issue here, or the argument here, is what should this mix have been? That's the point, right? What this mix. So this is what it should. Yes, and this is what it actually was. So that's what we're interested in. So I'm going to take that 11,000 and split in this ratio. That's the ratio I'm interested. 30 to 20. So I suppose it's 3 over 5 for A and 2 over 5 for B. Yeah. So I'm going to take 3/5 of 11,000. So 3/5 of 11,000 is 6,600. So you should have used 6,600 for A, and you should have used 4,400 for B. Yeah, you should have done this. That was the plan. Right. So the question then becomes, what is that? What is this variance? That's a mixed variance, right? So here, if you did 7,000, but you should have done 6,000. So this is adverse. You did 400 more than you should have, right? Here you should have done 4,400, but you did 4,000. So that's 400 favorable because you did less than you should have. So typically now we just, again, like I say, multiply this by the standard cost here. Here it's a cost of £4 for A, £4 per litre, and here it's a cost of £5 per litre. Right? So typically, mixed variances are favorable because you tend to use more of the cheaper stuff because and less of the more expensive material. So yes, so here we have 1,600 adverse, and here we have 2,000 favorable. So overall, this leads you to a 400 favorable variance, right? And that's how you deal with this. So that's the kind of the process. So your aim is always to come and focus on the amount that was actually used. If the question had asked about efficiency, then we would be asking a different question, be looking at what came out and what you put in and all that. But in terms of the mix, we're just going to trust you and go with you and say, well, that's what you chose to use. Let's see what your saving was, and let's see if that could compensated whatever efficiency losses you would have experienced in the end. Okay, great stuff. Right, so relevant costing. Relevant costing is very much marginal costing, short-term decision making. We make decisions in the short term, depending on what the scenario is. So sometimes opportunities come up that weren't planned for. Actually, this last point, opportunities coming up, are an example of that opportunity is where there's an opportunity for making extra sales in the short term. So these two are very similar, 2 and 4, because these are aligned. And so that's when we really use relevant costing. Now, typically, if you have scenarios where you are you're seeing changes that you weren't expecting, so actual activity will be lower than budgeted, you could use relevant costing to adjust in the short term just to make things align. Relevant costing is very much about being active in doing something, taking advantage or adjusting or adapting. So 1, 2, and 4 are very much in line with relevant costing. But when you have things very much in line with budget and things are working, and there probably is no capacity and not much change, then maybe you can argue that relevant costing here is not appropriate. But um, but for the others, relevant costing would be important. Yeah, there you are. Right, and in this final question in quiz 7, it says the company receives a special order. They need 1,000 kilograms of sand. The company currently has 600 kilograms of sand in stock at a book value of £2. So that book value of £2 is totally irrelevant because in terms of making a decision, it's an old cost, it's a sunk cost. Has nothing to do with decision making, has everything to do with reporting, but not decision making. And this question actually is not too tricky in that to buy sand is currently costing £4. It says the company uses sand regularly. So even if you took their sand, you would need to replace it. So I suppose another way of looking at it is saying, listen, just go and buy your own sand. To that department, just go and buy your own sand at £4. So that becomes regular. Because even if you say take their sand, you would need to replace it, and then you need to then um, buy another 400. So replacing it would still cost you £4, and buying another would still cost you £4. So there you are. So ultimately, the relevant cost is £4,000, which is, if you like, the cost of buying 1,000 kilograms. Cool, great stuff. And that is the end of